Okay, so question number 9. We have two shapes of walking tracks are shown, track 1 and track 2. And we're given equations of track 1 and track 2, but there's an A and there's a B in each of the equations. And the first one is a verification. Okay, just for 1 mark. So if f of 0 equals 12, then I know that A minus 0 times 0 minus 2 squared equals 12, which means A equals 12. Done. And G of 1 equals 9. So 12 times 1 plus B times 1 squared equals 9. 12 plus B equals 9. B equals 9 minus 12. B equals negative 3. Done. Verified that. So that's correct for 1 mark. Part B is also a verification, and that point P is a turning point for both. And turning points will happen when the derivatives are equal to 0. So now I know that f of x equals not A, but A equals 12. So it's going to be 12 minus x times x minus 2 squared, which is 12 minus x times x squared minus 4 squared plus 4, which is 12 minus x to the cubed plus 4x squared minus 4x, and f dash of x equals minus 3x squared plus 8x minus 4. If that is equal to 0, equals minus 3x squared plus 8x minus 4. I could have 3x and x with a negative on the 3. I can have 2 and 2, that's a plus with the negative down here. That times that gives me 6x, that times that gives me 2x, add them together gives me 3x. Therefore I've got minus 3x plus 2 and x minus 2. Therefore x equals 2/3 or 2. And the same thing goes with g of x. G of x equals b is negative 3. 12x minus 3x squared g dash of x equals 12 minus 6x. That will equal 0 when x equals 2. Therefore, both of them are stationary points at x equals 2. Therefore, g of 2 equals 12 times 2 minus 3 times 2 squared, 24 minus 12, 12. Therefore, the coordinates of P are 2 and 12. Now, part C, a theme park is planned whose boundaries will form the triangle O to A to B, where O is the origin, A is at K0, so that's at A0, and B is at K, G of K. And K has to go from 0 to 4. Find the maximum possible area of the theme park. Okay, so the area expression for the theme park will be A of K. It's going to be a half base times height. A half, my base will be, that will be K, and the height of this will be G of K. It's going to be a half times K times G of K, and G of K is this here, 12k minus 3k squared. So I've got my half k times this will give me 6k squared minus 3 on 2k cubed is an expression for the area, and we want to maximise or minimise this. We want the maximum, therefore I'd like to take the derivative and set it equal to 0. So 0 equals 12k minus 3 times 3 is 9 on 2k squared. 0 equals a equals 3, so 8/3. So that's the value of k. That's going to maximise the area, and we need to find the maximum possible area. So if area equals this, therefore A of 8/3 will equal 6 times 8/3 squared minus 3 on 2 times 8/3 cubed, which would be 6 times 64 on 9 minus 3 on 2 times 64 on 9 times another 8/3. So 3 goes into that twice, goes into that 3 times. 128 on 3 minus 3 goes into that, 3 goes into that, 2 goes into that 4 times. So it's going to be 64 times 4, which is 16, carry 1, 256. So 256 on 9, which will minus 256 will be 14, 8, carry 6 to 128 on 9. So subbing in 8/3, we end up with an area of 128 on 9 square units when k equals 8/3.